Hello, everybody. Welcome back. It's James here again on the Flocode podcast. Today, we got a special guest, Mr. Craig Brinck. He's joining us from Utah, USA. Craig's a structural engineer that works with Carollo Engineers. He's got about 18 years of experience in the heavy civil sector, and a lot of his experience actually crosses over with some of my own. But the topic that we are going to talk about today is his incredible library for finite element analysis for Python called Pynite. Anybody that subscribes to the newsletter knows that I'm a big fan of Pynite, and I'm very pleased to welcome Craig. So, Craig, welcome aboard, and thanks for doing this.
Hi, thanks for having me. I'm excited to be here.
Good stuff. So, let's start at the start. Your background. Wait, I got ahead of myself. My number one question that I always ask first is, what is your life philosophy in a nutshell?
My life philosophy in a nutshell. Wow, I've never been asked that.
I like to put people on the spot immediately, straight out
Boy,
of the gates.
well, I guess it's the pursuit of truth. I feel that is important. I find that pursuing truth is I don't know. It challenges me and it forces me to change. I find often I'm not in alignment with new truth that I find, and I look for truth wherever I can find it. I think religion. My religion. I'm a very religious person, so I pursue truth there, and I think also science. I love the truth I find in science, and I think those two are not incompatible. So.
Very cool, and probably more poignant today than ever before with the masses of misinformation and shenanigans afoot.
Yeah, you go online, and I like to tell people that when you go online, what you get is you get public opinion, and sometimes public opinion is correct, and sometimes it's incorrect. So, learning how to recognize truth and how to follow what is true and how to discern what is not true can be very tricky.
I
So,
heard a great, and that reminds me of a great analogy that I heard recently about public opinion and how if you're at 40,000 feet flying over the Pacific Ocean, you don't want public opinion to dictate how the aircraft is controlled.
yeah, yeah, and that feeds into AI recently, right? Some of the stuff I see AI kicking out, it's just drawing on public opinion to form its opinions, and sometimes it hits the mark, and other times it's way off. So
That's right. Okay, well, I'm sure we will touch on the capabilities of AI. So, give us a bit of context on your engineering background, where you started, what kind of stuff you've been working on, and then we'll slowly dig into Pynite.
yeah, so I started out actually as a computer science major. Thought I wanted to be a computer programmer, and switched shortly into college, and started into structural engineering. And I've um, always loved structural engineering. My grandpa was an architect, and he kind of pushed me away from architecture, and structural was kind of the next thing. Um, he told me there's a lot of starving architects out there, so
Hmm.
he kind of said it's a great profession, but and that's where structural came in. Um, as far as Pynite's concerned, I started taking finite element courses and really enjoyed it, and thought, oh, this is something I could combine my computer skills with, and that's it started out with Excel and then
Hmm.
moved into Visual Basic,
Hmm.
and then I discovered Python, which was really built for this stuff. So
Um, Finite element theory in itself is not something that you have a whole lot of opportunity in university to tackle at great depth. Um, you kind of get exposed to it a little bit. And I know for me, when I was in university, I was so curious about the big shiny commercial packages that had the cool outputs and the cool animations, and that's where my focus was on. And if I could go back, I would tell myself, now that you have the time and the space, like dig into the theory a little bit more, learn about plates and shells in a little bit more detail, because once you start working, you're against the clock and you're scrambling to learn as
Yeah.
fast as you can with the time available.
Yeah, I remember in college I took two finite element courses, and the second one I took, I remember we started getting to the theory of plates and shells, and it was so far over my head, and I
Yeah,
was against the clock there in class. I remember staying up till midnight trying to understand the stuff in the computer labs, um, and
it's
I
brutal.
felt like
It's brutal
it,
stuff.
it was brutal stuff, and I never really had time, even in college, to understand it well. Skirted by that class with a B somehow. Um, but actually, in the profession, I thought I want to go back and relearn that. I want to understand what my software is doing, because I've used a lot of commercial packages too, and I remember right out of college, I thought, oh, this is cool stuff. I can analyze anything. And now, 18 years into my career, I've realized kind of the error in that line of thinking. I've probably screwed up some things in the process of thinking that my finite element model was doing things that it really wasn't.
Yeah,
So
yeah, and it's almost as if your objective might be to cross a small stream, and instead of jumping over the rocks, you get into a giant ocean liner to try and cross over.
yeah,
Like there's so much going on in those tools that even just to set up a simple model, you've got to run through many checkboxes and many things. And that's the beauty of Pynite is it's lean and it has what you need to quickly piece together like fundamental structural behavior. That's how I use it most frequently.
yeah, and that's how I use it. I mean, there are other packages out there. OpenSea's Pi is one that comes to mind, which is a great package. I don't want to say anything against OpenSea's Pi. I just find that the learning curve on that is quite a bit steeper. Pynite, if you want a real quick, simple model, it'll do it fast.
So when did Pynite start? And wait a second, I guess we should, for people that are unfamiliar with Pynite, Craig, please provide in your own words what it is, what it's for, and how engineers can use it.
Yeah, so it's basically just a Python basic finite element package. It does beams, it does columns, it does plates. It manages your load combinations for you. It creates visualizations of your model. It will show deformed shapes and loading and things like that. It'll produce moment and shear diagrams for members. So it's just a general purpose, linear elastic at this point, finite element package. It won't do a ton of nonlinear stuff, although it does do p delta, which is nonlinear, and it does do tension and compression only members, which are nonlinear. Um, so yeah, it's a general purpose package. It's pretty basic, pretty simple, and my goal has been to keep it easy to use. And I don't know what else to say about it.
Well, I think it's important to note that this is a project that is live on GitHub, and this is a project that people can fork and they can contribute to, they can modify, they can use it as a scaffolding to build their own tools, which I've done that quite a bit. It's with many aspects of Pynite, and it's been very helpful in a professional context for validation of stuff from commercial tools and just for quickly iterating on conceptual designs. So if anyone's curious out there, go to github.com. What's your GitHub? JWalk82?
Jaywalk 82, yep, and it's just under Pynite. Another way, if you're fairly savvy with Python and you've got pip installed, you can install it through pip install Pynite FEA, and that will download it and install it into Python for you.
Highly recommend you guys checking that out. And he also has a folder of examples in there that show you broadly how many of the different functions and methods can be used. So check that out along with the great documentation, which will dig into as well. Okay, so that's the bones of Pynite explained. When did you begin this project and how did it start?
Well, I guess I began it. I would say it morphed out of things I started in college, like those spreadsheets and things. I built a lot of code in college, or spreadsheets in college. It moved into, like I said, VBA at some point, and then I took that VBA code and started. It was for 2D frames, and then I started converting that into code for 3D frames in Python. And I started moving it into Python probably in 2017 in my free time, just kind of as a hobby.
Yeah.
Kind of after work, just come home, click on the keyboard. I had young kids at the time, couldn't really get out of the house. Um, so stuck at home, may as well write some code, right?
I'm in a similar boat right now.
Yeah, my kids are growing up a little more and they're demanding a little more of my time now, which is making it harder to code. So, um, but yeah, that's, I would say 2017 is really when the project kind of branched off and started doing its own thing.
You know,
Um,
it's interesting that you mentioned the start in VBA because I think there's a lot of engineers out there that are very comfortable in Excel and VBA, and VBA is a very difficult language to use and to debug. And I know that a lot of people that have learned it, they don't want to think about all that time that they spent and go, I don't want to learn another language.
and Yeah, and what I found with VBA was, first off, it was a natural step from VBA to Python. Python was so much simpler. The other thing is with VBA, I got to the point where I was building custom classes to manage vectors and matrices because dynamic memory in VBA is very difficult. It's resizing arrays is a pain. If you got a static array, that's fine, but a dynamic array, really a pain in VBA. And so I went to Python and found that it managed that so much better for me. It's got libraries like NumPy and SciPy that are already built that do the math for you. In VBA, I had to write the code to invert a stiffness matrix.
It's
It,
crazy. To have to dig into all of that stuff to just do something that's so fundamentally simple in Python is,
yeah,
I mean, it's so slow for you from a development
yeah.
perspective. Um, but I guess my point on that was VBA is a very difficult language, and if you're comfortable in VBA, you're going to blossom
You'll
with Python if you
you'll pick
transition.
up Python in no time. It took me, I don't know, a few lines of code, and I had already started picking up on it, and you learn as you go.
What about I guess now that we're on this topic, the aspect of environment management, the aspect of dealing with a shell, setting up a project and dependencies. There's a lot of baggage that comes with basic Python usage that is repulsive to a lot of people. That,
Yeah,
that's the pushback I get when I try to explain to people, they see the use cases and they're like, wow, I get it. The language itself looks very efficient. I can see what you're doing. But then when they try to do it, they're screaming at their screens because they can't get past setting up virtual environments and et cetera, et cetera. What do
so
you
the
have to say
way
about that?
yeah, the way I learned it was, and again, that was all new to me when I started in 2017 with Python. I would say now 2024, I understand all that stuff. But when I first started coding it, I ignored virtual environments. I just installed it all under the same directory,
Me too.
and that stuff came with time later on, where it's like, oh, that's why you don't understand what a virtual environment is until you start seeing the need for it. When you
Yeah.
start using somebody else's package, and you realize, oh, that version has some changes from the version I built this off of.
Yes.
Virtual environments are all about interfacing with other people's code, right? Making sure you're compatible. Um, so I would say if that's the problem, download it off of Anaconda or something where they manage all that stuff for you, and
Yeah.
don't worry about it. And then it'll come. It'll come when it comes.
Yes, and the cloud notebooks like Google Colab is also a great option just to get you up and running. So you started with 2D frames and then you moved into 3D frames.
3D frames. Yep. I,
And so I guess, when I was thinking about how I was going to, like, because we can't talk about the nuts and bolts of Pynite, that would be a horrific listen
boring
for people
conversation.
to go through. But what I will say is that if anyone is curious about how on earth you would piece together a tool like this, is in the documentation there's I think there's a fundamentals section,
Mm-hmm.
and it basically gives you all of the different methods and parameters that are modifiable as a user, and that gives you a real good skeleton of how Pynite works. So how did you come up with that? Like, how did you come up with the framework of it all? Because it's very well laid out.
I'd say it's kind of been forming in my head for years. As I think it was object oriented programming. I don't know how familiar everybody is with that term, but um, this idea that when you're modeling an object, you're really modeling reality, and so you start to think, how am I going to organize? How would I organize this in on paper or in the real world? Well, a beam is an object, right, in real life. And so I wrote code that represents a beam. And even more, I could break that down into a sub object. Well, there's a mathematically continuous segment on a beam, right? So I modeled a segment, and then I attach that segment to the beam, and then I attach that beam to the structure. And so you model objects the way you would think of them in reality, and you link them to each other. And that way, when one thing changes, it's reflected throughout the whole model. Um, and you don't have to do the bookkeeping yourself.
And when it comes to the solving these matrices and understanding like what was the best way to do this, you must have had some serious roadblocks where you were just
Uh,
pulling out your
trial and
hair.
error,
Yeah.
trial and error, a lot of trial and error. It started out with really simple force equals stiffness times displacement matrix algebra, right?
Yeah.
And then you got your fixed end reactions there, but um, and that was pretty simple. And then you find that, oh man, that works great for beam models, but when you get into plates, that's super slow to be inverting stiffness matrices. And so then you go look for a library like, how else do people do this? How do they make this work faster? Oh, look, NumPy's got a function for that. And so it really started out with just doing the basics, one small little step at a time. Someone issues or gives me an issue and says, "Hey, I found this issue with your code. I think it could work better if you did this." And I'm like, "Oh my goodness, he's right. Let me change that." So
Yeah.
a little
And
bit
how
at a
did you try to incorporate Pynite in a professional context earlier on?
I
Like,
I think I had the idea to use it professionally at some point, but there really wasn't a practical use case for it at work initially because um, we had finite element software already that we were using. It was so much faster. Um, but as it's gotten bigger and bigger and bigger, I've found use cases for it at work to model some complex things that maybe those commercial tools don't do. A case in point is shear walls. There's some things with shear walls that I found commercial software struggles with, and I've been able to work around that with Pynite.
like concrete shear wall, like as in,
Concrete and masonry shear walls, yeah, I do a lot of seismic shear walls at work, and so um, to give you an example of that would be orthotropic behavior in the plates, right? Um, we know that when you load a shear wall laterally, that it develops flexural cracks, right, as it approaches ultimate. And most software has a hard time modeling that flexural cracking. And so Pynite, I just set a separate stiffness vertically than horizontally, and that can be modeled. So
I guess the beauty of it is it's an open book, so you understand the limiting assumptions. The code is exposed. You can see where it begins and ends. Whereas sometimes, I mean, a tool that I've used a lot is SAP 2000 for a lot of different
mhm.
things, and it's a great tool, very flexible. But there have been many instances where something doesn't quite make sense, and I have no idea how to solve this problem. So
Yeah.
I end up trying to replicate it maybe in another commercial tool, or I try to check it from first principles. But when it comes to what's actually happening in the software, maybe somebody from CSI structures will respond, but historically it hasn't been very successful.
Well, and I'm not going to call out any specific software, but I will say I've used. There's one package I'm thinking of that I've used that boasted that it could do masonry shear walls. And as I got looking into I spent a lot of time studying seismic shear walls. It's part of my master's degree, and the plastic behavior of those walls. And as I got looking into what it was doing and what the building code actually said, I could see that there were some concepts missing from the people who programmed it. And it's like, well, what do I do here? I've got a big shear wall building that's using this code that has a few flaws in it. And so I just built out some features in Pynite that took care of it. And so Pynite is, it's a smaller program. It can't do as much as a lot of those commercial softwares. But if you have a niche need,
Yeah.
it's very easy to quickly build out Pynite to fill that need.
Yeah. Yeah, I couldn't agree more. And a lot of my projects are in the energy and the water sector, so it's a lot of big mass structures, it's pipelines, and it's a lot of stuff with weird, irregular geometry or some sort of an unusual problem that might not fit into the kind of more cookie cutter commercial tools. And it's situations like that. It might be like a simplified frame or like a lifting rig or some sort of temporary construction situation where I just need to figure this out from a first principles perspective, like what's happening. And that's where I see personally the use cases for me for Pynite. And then you also don't have to wrestle with licenses around the office or
Yeah,
some sort of constraints that a commercial tool will bring. And Pynite is free, so I think that's a
it
big
is.
deal.
Yeah, it's just some middle aged guy working in his office late at night, kind of doing it as a hobby. So it's free to use, and the reason I do that is as I share it with people, I get input from people, and they help me debug it.
Yeah.
I get questions all the time. Hey, I think it should do this or that, and it to me it makes my code more robust, and it puts me in charge of my own engineering instead of being beholden to the big software companies.
And I would imagine for you personally, the pursuit of trying to build Pynite has massively reinforced your own understanding of fundamental structural engineering concepts.
Yeah, I would say, I go into software or finite element models now, and when I can spot problems right off the bat, right? Like, oh, hey, we're missing this or that, or well, what kind of plate is this program using? What assumptions are built into that plate element that program uses? And I can tell you, even amongst the commercial software, a lot of them have very different behavior in their plate elements. And if you're not careful, you might run into a gotcha in very specific situations. So it's good to know what your software is doing.
And have you just, I guess, in the context of your own work environment, have you been pushing the use of Pynite or trying to get people on board with how useful it is? I'd imagine
You
people.
know, I'm probably running into the same thing you are. Python is a scary word to a lot of structural engineers. I'm not sure I understand that or why. I think it's it's because it's unfamiliar and unknown. But sometimes, like I said early on, I think pursuing truth sometimes means stepping outside of our comfort zone and moving into things we've never explored before.
Yeah.
And so I don't know. I think I've shared a few of my tools around the office to help out whenever they're needed. Um, but I don't want to become the Python maintainer for the whole company. That would be a full time job, and I would get none of my projects done. So
Sure.
I don't know. I'll endorse it, and if anyone wants to use it at work, I'd be happy to help them. But unfortunately, I don't know what it is. It's
I think it's just the initial learning cost is so high,
yeah,
and it just takes, you have to be interested in it. You have to think. It's not quite, it's not easy at the very beginning, but it is worth it. And you could say the same thing about Microsoft Excel. Like back in the
yeah,
80s, whenever people started doing stuff in Excel, I'm sure that there was a lot of senior
yeah,
engineers who were like, "Get this thing out of here! Like, what are you? This is massively overcomplicating everything."
yeah. And I think one reason I posted examples on Pynite's website on his GitHub page is just to help people get started. I mean, those examples, if you look at them, they're very basic. I've had a few people submit very complex examples and want me to post them in there. And I don't like doing that because to me, those examples are for entry level structural engineers. Those are not for coders. Those examples are meant for a structural engineer to be able to come in, see what the code does right off the bat, and know how to get into it with very little effort. So
That begs an interesting question though, because you know every every piece of engineering is derivative upon something else. So having a folder of more complex or advanced case studies, as it were, is
mhm.
it's an interesting idea. But yeah, I understand you don't want to be scaring people away with
Yeah, I
raw.
mean, I've got to give you an example. I've got a spreadsheet that does rigid diaphragm analysis, right? And then I've hooked it into, I've built out a module on Pynite that does shear walls, and I've hooked that into my rigid diaphragm spreadsheet so that they talk to each other, and so I can design the whole building top to bottom with Pynite and Excel. But to put that in front of users, I think it would scare a lot of people away. I understand Pynite really well, and so I can I can do something like that myself. But expecting new
Interesting.
users to come in and pick up on that might not be fair.
And so you mentioned obviously that life gets in the way. It's difficult for you to maintain the library at the same rate that you were previously as you were building things. So, what is your sort of long term plans with Pynite? Like, are you
Yeah,
working on specific aspects of it?
yeah. So right now I'm kind of working on improving the plates. Something I've been working on for a few months now, and it's a pain for me because I've hit a few snags, but it's a learning opportunity. So I do plan on continuing to improve Pynite going forward. Probably not at the same pace as I was 4 or 5 years ago. I am looking for people who want to maintain it and help me maintain it. What I got to be careful about though is I think there are a lot of maintainers that would um, take it in a direction where I wouldn't understand the code anymore. Right? I'm a structural engineer. I'm not a coder. I mean, I do code, but I'm primarily a structural engineer, and what I don't want is for the code to become so obscure that I can't contribute to it anymore, right?
Mm, yeah, I
I
think
think,
isn't that the curse of all sort of code type open source projects, where a good example is I don't know if you're familiar with QGIS, the open source tool for GIS, but you can see the development of that started off as one guy, and then over the last 20 years, you can see the nodes expand and the capabilities expand. And that thing is an absolute monstrosity now, with stuff that I'd imagine the original developer never even
Yeah.
considered.
And
And it's a tough decision for you to make because it's your project, yet
yep.
people can contribute, but ultimately it's up to you what direction you want to take it in.
Yeah, and I think the way I'd like to take it eventually is to get kind of a steering committee, get a few contributors who are a little more familiar with the code, who've kind of proven themselves through doing submitting things to it and getting them approved. And once that relationship of trust is there, then I think it's like, okay, well, let's have a few of us now working on this together, and it'll ultimately invite, I want the community's input on this program, because I can't do it all myself, and someday, probably 30 years from now, someday I'm going to retire, maybe. um, and but I would like this to keep going after I'm gone, and so that's where I need more maintainers and helpers. um, but I think a key to it for right now is keeping it simple, keeping it, because I'm getting to the point now where I get more, 4 or 5 years ago, I would get maybe an issue every week or two, or every month or two. It wasn't often. It was probably once or twice a month I'd get an issue.
Yep.
Um, and now it seems like once a week there's somebody commenting on an issue, or asking a question about something, and having a hard time keeping up with it now. And so I do need help. Uh, if it's to expand at the rate that I think the community wants it to, I think I need people to step forward and say, I'm willing to help. And then I think it's a matter of also setting up some kind of approval process for getting changes, where it's not just one person can make any change they want. It's got to be a few key people that two or three of them look at it and say, yeah, I agree with this. Let's incorporate this. So I'm not sure what that looks like, but I think that's going to develop in the next few years.
Yep. Yep. Yeah. It's interesting. It started off as your personal project, and now it's slowly growing legs. And
Yeah, it wants to walk on its own, and it's like watching your child walk away, right, off to school, and I just raised you. Can't you stay a little longer?
yeah.
But
So what about let's imagine a world where Craig has lots of free time to, play around and add to Pynite. What is on your wish list of stuff that you want in there?
oh gosh, I'll tell you first, this plate issue that I want to get taken care of. I think this is really going to streamline usage of plates.
So can
Um,
can you can you summarize what is the plate issue that you're dealing with?
Yeah, so right now Pynite uses an MITC4 plate, which it's a good plate. It was derived in the 80s, I believe, um, but it does have some limitations. And actually, a lot of commercial software uses this same plate. But when you go look at corner stresses, it's usually reporting center stresses, even when you
Hmm.
ask for corner stress. So you got to be careful when you're dealing with a boundary edge. Say a fixed joint, and you're looking at bending moments. Um, you might be getting the moment out some distance away from the face of the support rather than at the support. So
Hmm.
that's just for bending. For in and out of plane, shear wall type stuff, it actually does pretty good.
So do you have
Um,
like workarounds for something like that, where usually
yeah, so
I'll
there's
reduce the plate size or something like that?
you would reduce the plate size. Right now, Pynite has two plate elements in it. There's a quad element and a plate element, and that's to help deal with this issue. The plate element only works with rectangles, unfortunately, but it does do really good corner stresses. The quad element is the MITC4 element, and it does great for quads, but it also doesn't do great at corner stresses. So
Hmm.
it's mostly center stresses you're getting out of that. So
Okay.
right now, Pynite has two plate elements. I would like to consolidate that to one element. There's one called the DKMQ that I'm working on, and it's a newer derivation. I think it came about in the 90s, I want to say. And there's a few commercial packages that use that element instead. So
Okay, cool. I'm not familiar with that one. I'll check that out.
yeah, I'm trying to upgrade the plate elements, reduce. Right now, I got two elements. I'd like to consolidate that to one. Like I said before, simplicity. I want the program to be simple.
You mentioned before that Pynite is it's all linear elastic right now, except for the P
Mhm.
delta stuff.
Yep.
Will we see non-linearity in Pynite?
So so I started working late last year on pushover analysis, um, and I got pretty far, and then I hit another brick wall, and I just had to pull myself away from it. It was taking a lot of time. I think given more time, I could finish it, but so it's half baked into Pynite right now. Um, if I had all the time in the world, that would be another project I think I would take up is pushover analysis. It's something that's always intrigued me.
You know, the thing that's difficult about this is that on first of all, you have to have a solid grasp of the fundamental theory of what you're trying to do.
Mm-hmm.
But not only that, you're not just trying to get something to work. You're trying to get something to work and present it in a usable way.
Yeah,
So you kind of have to know first you have to get to the finish line, and then you have to come back, evaluate the journey, and be like, okay, we got to move this section over here, we got to move this over here, we got to do this like this. And
yeah.
the whole process is it's I can't imagine. That's why when I'm using the tool, I'm struggling to try and figure out what I need to do in the moment. And I can only imagine that is, times 100x when you're sitting there trying to figure out what's the best way to do this.
Well, it's probably the same. I the way Pynite has been built out is as I've found needs for it. So, give you an example of that is load combinations. I was originally Pynite did not do load combinations, and at some point I was like, you know what, this would just be so much more useful if it had load combinations built in.
Yeah.
And so, so I bit the bullet and spent a lot of time refactoring the code, redoing the code to incorporate load combinations, and yeah, it took a lot of work, but it was just one step at a time. Like I really need this feature. That's the next thing I'm going for.
Have you been using much AI tools to help with your coding?
Now that's a good question. So I've started tinkering with AI about a year ago, and I did as I was developing a shear wall. I was trying to find an algorithm to break the wall down into segments for the shear wall because we don't analyze when you get a wall with holes in it. You got to break it into piers and look at the aspect ratio of each pier, right? That's actually pretty tricky when you got some complex wall arrangements. How do I break this down with a set of rules that will work every time?
Hmm.
And I actually came up with an algorithm, but I had AI kind of code it for me as I went. So I said, "This is what I want it to do," and so I used AI to kind of guide my code. It did a great job, and it worked out really well. So I would say yes, going forward. Um, I plan on using AI as much as I can.
Yeah.
Some of the more technical issues AI just can't help out with. I ask it for the stiffness matrix for a plate, and it can't do it. It doesn't know what it's trying to find.
Yeah. And, you know, there's a lot of limitations, but a lot of it can come down to the clarity in your question or your prompt.
Mm-hmm.
And I think that's a skill that you can get better at. At the beginning, the questions or the prompts I was using were kind of like not very clear. But then as you have a little bit of back and forth, you sharpen the pencil, and then your questions become more pointed, and then you can improve that as a skill. And as you mentioned, it's a tremendous tool, but it's just kind of loses if the problem is too big, it just loses traction
Yeah,
and
yeah,
becomes a
and
bunch of
you have to
garbage.
You have to break it into little problems. Exactly. I remember Pynite on the visualization was showing load values out to like 16 decimal places. And I thought, okay, this is a unitless program. So the user could have big units or small units. I don't know what they're going to have. Really, what I need is just to keep the significant figures. And so I asked AI, give me a method that rounds a number to X number of significant figures. And it helped me with that. It just wrote that
Yeah,
method for me. And nothing mission critical, right? But it just, um,
it's 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 a phenomenal tool, and we've been building an internal sort of sandboxed version of ChatGPT where enterprise data is protected, and I will often turn on the dictation feature on my in the prompt box, and I'll verbally elaborate on like a problem or something I need to prepare. Maybe it's like specifications, or maybe it's even like an email explaining a certain situation. And I'm not quite sure how to word it. Or the way sometimes you look at a blank page and you're just like, I don't even know where to begin with this. And it helps me to brainstorm and go back and forth and then end up with something useful that I can then shape, and saves time. It's a silly way of doing it, but I find it very helpful.
yeah, yeah, it's, I don't think fearing AI is the right way, right? It's being wise in our use of it. I
What
think
are
one.
your what are your opinions on younger engineers leveraging AI?
I thought about this for my own company. Like, do I? It would be really nice. We have some practice manuals for the engineering department. I was tinkering with it. Like, maybe I can upload these into Chat GPT, and when a young engineer has a question, you go to this bot we've created and ask the bot the question and see if it gives answers. I haven't found it giving super good answers though, and so um, I think it'll get there. We're just seeing the beginning of this, but I think eventually, yeah, I think it's a great opportunity for engineers to learn. I learn from it. I ask it questions, and I look at it kind of with a careful eye. Like, do I really believe what it's telling me, or sometimes I ask, "What's your source on this?" And it says, "I don't have one."
Yeah. And I feel like I'm starting to get a feel for, you know, if I get an email and I read the email, I have a feeling that like this was regurgitated out of ChatGPT, or
Yeah,
I think
yeah,
everyone's starting to get that feeling now where they recognize this kind of bland AI tone.
hmm yeah. And I've actually used it to help me write emails before. Usually it's when I'm upset at a decision that's been made on a project. I'll write out what I want to say, and then I'll hand it off to Chat GPT and say, "Could you make this kind and nice
Yeah,
and politically correct?" Because I'm
yeah,
not good at that.
that's good. Yeah. Um, okay, so I guess, can you give people sort of an outline if they're interested in using Pynite? I think the best place to start is the documentation and the examples. But what would you say in your own words?
Yeah, I think it depends on the user you're talking to. So if you're talking to, let's assume you're talking to just a normal structural engineer who doesn't have much coding experience. Is that fair?
Yeah,
I would say to them, the documentation will be very helpful getting you installed. But I would also say, um, I think I'd say look at those examples, those Pynite examples. The code is so simple, and they're simple things like a simple beam or a moment frame or a shear wall. It shows you how to do that. Look at those examples, um, and I think just about anybody can figure out what those examples are doing because I've commented step by step along with the example. Here's what this step does. Here's what that step does. So that's where I would start. The other place I would start for a new structural engineer getting into Python, I learned a lot of it on what was it? Code. There's there's some websites that can teach you how to code in Python. Within a few hours, you'll get the basics. I'm trying to remember what it was called.
Code Academy, maybe?
Code Academy, that was it. Yeah. So I just tinkered in there for a few hours till I felt like I'd learned a few things, and do that for a few hours. Then go to Anaconda's website or whoever you want your provider to be. I thought Anaconda was great, and download Python from Anaconda. That'll take care of the environments and all the stuff you don't want to mess with as a new user. Um, and then from there, find your environment you want to work in. So with Anaconda, it'll download Jupyter, it'll download Spider. Those are both very good programs for coding in Python. Um, yeah, look
What
at the
what's
examples
your
and try it.
what's your personal coding environment set up like? What do you like to use?
So I actually use VS Code. I do like Spider from time to time. Um, and sometimes I'll use Jupyter Lab.
Hmm.
So
And
I
for
generally use
environment
it.
management?
For environment management, I actually do that manually through VE.
Yeah.
Maybe that's the hard way to do it, but
Yep.
I'll just use Python's built-in.
I use um I use VS Code and Poetry, and I use Jupyter notebooks within VS Code. And
Okay.
most of the time, I'm iterating through a design, and I like to work in a notebook because it helps me keep track of my
Yep.
thoughts and my notes and my references.
And I do that with Pynite. I don't know if you've looked on Pynite's GitHub page, but there's a repository of derivations in there. So if you want to see how I derived the plate element, you can go in there, and there's a Jupyter notebook with the whole derivation in there.
Cool. I didn't know that.
Yeah, yeah. I'm working on one for the DKMQ as well, but I'm trying to be open with Pynite. It's my learning tool, and the nice thing about Jupyter Lab is when I'm deriving this stuff, I can use a library like SymPy, and it will handle all the tough numerical integration or raw integration. Right?
Yeah.
Um, I can throw some matrices at it, and it'll crunch them for me symbolically.
That brings up an important point because, a couple of times when I've mentioned Pynite to people, they say, why would you want to recreate a finite element software when there's already commercial tools that can do this? And I usually say, well, first of all, it's free, and there's a lot of individual engineers and companies around the world that don't have the luxury of a $30,000 per
Yeah,
seat structural tool. And the second thing is as you had mentioned earlier, the you're not building it from scratch. Like, you've already built the framework. Like, you're really just writing functions and
yeah,
defining, and then you're leveraging all of the derivations and the work that you've already put in. So while people think you've used Pynite to build an FE tool, that's not true. It already is a functioning FE tool. You're just
correct.
you're using it. You're using the functions and the pre-built capabilities to get whatever answers you need to get.
Yeah, and you mentioned a couple things there that I think stick out to me. I spent 2 years in Africa, and when I see somebody from Africa using this tool, I know they probably don't. I probably don't have access to a lot of the finite element tools we have here in the states. So I feel really glad when I see people from some of these developing countries can use it. I also feel a little scared that they're going to use it wrong, right? I want to make sure they're using it right, but
Yeah,
I do like that we are helping other countries build their infrastructure too. Helping some of these countries that don't have the resources we have.
absolutely.
So
And I think too, Craig, that that's one of the strongest cases for Python is this democratizes scientific computing across the planet, and you can build whatever you want to build. The tools are there and they're free, which I just think is a huge missed opportunity for many people that don't investigate this further. But I know I'm preaching to the choir.
yeah, I feel like we are kind of subject to the commercial software industry sometimes, and I would like to see more structural engineers get involved in this project and see us kind of take ownership of our own profession, and because I mean, let's be honest, if anybody who's practicing structural engineering knows, it's hard. The timelines you're asked to do this stuff in, and the trying to get software that you need sometimes is a closed door. I don't know if you've had that experience, but there's been
Yep.
times they say, I need this piece of software, and the company says it's not in the budget. We've been fine without it for years and years. Why do you need it now? And so you just go build the tool, and then you're not reliant on others. Self-reliance, right?
It also, there's a lot. Most structural engineers out there are probably comfortable in a. They'll have a commercial tool of choice, and they can probably do a lot of stuff with that tool, and build a lot of cool models and get some interesting results. However, I'm sure if you were to sit down and kind of work through these models and ask individuals like, what's happening here? Or how does this work? We just don't have the time or the luxury to understand those kinds of things with these
Yeah.
commercial tools. So you're right. We're kind of hostage. We're hostage to the creators of these commercial tools. They're a closed black box.
Yeah, and I don't know if hostage is the right word. I don't think there's any malice, right?
I'm
But
being dramatic. It's dramatic
yeah,
effect.
no, but but when you switch jobs and your new firm uses a piece of software you don't like, um, Pynite is something you can use anywhere,
That's right.
um, for as long as your company's IT policy allows you to download it, which is another.
It's another hurdle. Okay, well,
Yeah,
we're running low on time here, Craig, and I just want to say thank you so much for the work that you've put into Pynite. It's extraordinary, and it's such a helpful tool. And I started using it maybe 4 years ago, and even I can see how, as you mentioned earlier, that more and more people are taking notice, and I think that that's the case with Python in the industry in general. More younger engineers understand the benefit of it. We have AI tools that can now sort of like augment your coding practices, make it easier to learn. So a huge thanks to you from me and from whoever else out there is using Pynite. Really appreciate it. And for the Flowcode listeners out there, if you're interested in helping Craig with the maintenance or with basically contributing to the project in any way, and I'm sure there's many different things that they could be doing, Craig, from helping with documentation or examples to code reviews, etc.
yeah, yeah. And, at this point, I feel like Pynite is kind of hitting a hinge point where um, I need to find a way to democratize it and get it out to the profession as a whole, because it is becoming more than I can handle as an individual.
We'll
Very
uh,
quick.
we'll start doing campaigns for non-linearity. We'll have it
Yeah,
like the presidential race.
yeah. I feel like I've gotten it kind of off the ground and doing the basics, and I just it does most of what I need it to do, and so there's not a lot of incentive for me anymore to really build out a ton of huge features. I kind of want to pass it on to the next person and say, what can you add to this to
That's
make
right.
this better for the community? So
That's right. I think you've done a lot as it is. So with that said, Craig, thank you very much for talking to us, and maybe we'll talk sometime down the line.
thanks.
Okay, everybody, that's it for today's episode. We'll check back in when we have more updates. Bye bye.